All right, cool. Well, thank you guys for coming. My name is Joshua Hoffman, as John mentioned, and this is Linux Containers from Scratch, Makefile MicroVPS, which is a bit of a sequel to my talk from last year, which was Linux Containers from Scratch. If you want to get a copy of the slides, they're available. They're up on SlideShare, and you can certainly get them later as well. So a little bit about what this is. I've had a couple people ask me, are you proposing some sort of alternative, that you made to use instead of Docker? And the answer is no. I think instead, though, whether you choose to use Docker or not, which is a fine tool, if you want to understand how Linux containers work, you have to be able to dig deeper. You have to really get in there, because the trouble with tools that are so automated and so easy is that when things go wrong, they tend to go really wrong. And on top of that, you have no experience troubleshooting the innards or trying to fix it or anything like that. And you're usually then sitting in some kind of worst case horrible outage, and you're on the fly trying to fix things. So what I like to do in terms of learning is to take things apart, and that's what we did last year. This year, we're going to take the pieces and build them into something that could actually be used, and go through what that looks like to build our own container system from scratch. So that's what this talk is all about. And because it's from scratch, I am literally going to start with a CentOS minimum install and build it from scratch, and hopefully it all works in front of you guys. I also firmly believe that you learn more when things don't work right away. So inevitably, I will make a typo somewhere, and we'll figure that out, and that'll be fun. So that's a little bit on what this is about. Slight recap from last time in that I make the point Linux containers do not exist. Right? There's not a thing. It is an idea that someone has come up with to combine some Linux technologies and create a container. And because these are a concept and not a thing, that means that you can't say exactly what a Linux container is. You can just say what it's like. So if you think of similar technologies like a Linux distro, right? A Linux distro, they're not all the same. There are many different ones. And in fact, if you go out in the hall, I could be wrong, but odds are you could strike up a passionate argument with one sentence just by saying, what's your favorite distro? Right? That immediately could launch into some very heated or hopefully very lively conversation. And just to drive the point home, a similar concept might be a sandwich. Right? If I ask every one of you to think of what a sandwich looks like, and I tell you there's a picture of a sandwich on the next slide, what do you think the odds are that what you're picturing is what you'll see? I don't know what the odds are. I'm not very good at math, but I do know that some of you may be thinking of exactly what's there, and some of you may be thinking of something entirely different. And the point is they're both equally valid as a sandwich. Right? So what makes a sandwich? Well, there are some common ingredients, but I don't think, and I'm willing to assert, you can't argue that there are definitive sandwich ingredients. Because if all of the ingredients are optional, then there's no definitive one. So for example, tomatoes. Who likes tomatoes? Yeah, pretty popular. Can you have a sandwich with no tomatoes? Yeah, of course. It's still a sandwich. So cucumbers, same deal, right? Bread. Some countries, it seems like toothpicks. I heard some shaking a head. Can you have a sandwich with no bread? Yeah, well, if you're in the US and you're doing this crazy protein diet thing, you can go to various restaurants and order a protein. They use lettuce for the bread. So it's like meat in a lettuce sandwich. It's still a sandwich, though, right? You can argue the finer points, but you get the idea. So we're not here to talk about sandwiches, of course. We're here to talk about Linux containers. Right? And what are the ingredients that make up a Linux container? Namespaces, and we talked about those in detail last year. And this is, of course, the different hallucinations that we can give to a process that's running so that it thinks the world is something different than what the host sees or what other processes see, and we'll see how we play with these. If you want more detail on them, there's a video of my previous talk. I think you can buy it from O'Reilly or find it free if you know how to use Google. Sorry. But the point is that goes into a lot of detail on these ingredients. C groups, these are the control groups. These are the things that allow us to place boundaries and limitations on running processes. Build automation. You could argue this is not necessarily an ingredient for containers, but I think if you're building anything and it's not automated, you're missing something, right? Like everything you build, hopefully, is an automated build process, and I think it's necessary for containers. And the last one is some kind of portable archive, right? Like, how do we take this in one file and send it somewhere else? Like, that seems to be a very popular ingredient, not necessarily a requirement, but some way we can move it around. So in the world of Linux container usage, right, so let's forget about the technology for a second, except for what do we put inside it? Right, well, what's the ideal container? The ideal container is that beautiful single process container that we just run that one thing. And that is, anywhere you look, that's the recommended usage. So if you follow the other end of that spectrum, you have, of course, the full operating system. And I argued last year that I think it's kind of silly to put a full operating system in a container because it's really inefficient. You're running processes that are trying to do things that are explicitly not allowed in a container, like potentially mounting file systems or even doing like an FS check on a file system that's already mounted when the container starts, so why would you be doing that? And all kinds of system initialization stuff. So it doesn't make sense to me to put the full OS. But at the same time, I don't think that this is the only place to go to have a single process. Is there a question? Is there somewhere in the middle? And that's what I want to explore today. Because I will make the case, I think there is a valid use for something more than a single process. But you can also argue that if you wrote the software yourself, you know it's a single process. Cool. Right? If you didn't write it and it's just something you want to run, say you're in a mail server and you're going to run postfix, is that a single process? How many people know postfix? How many people love postfix? Yeah, whatever. But it is by design a suite of processes. It is not a single process. So if you make a postfix container, it's running an orchestrated set of processes. And if you try to split all those little pieces into separate containers, you could probably get that done, but I don't think it's worth the investment of time it would take to figure out the intricacies and configuration necessary to make that work. And I don't think it'd be worth the benefit anyway. I think you'd be wasting your time. So I have come up with this concept, I just made it up, called the MicroVPS. Because if a virtual private server is a whole OS running on some kind of virtual machine somewhere, what is a MicroVPS? That is meant to be the smallest sort of usable thing that's like a little virtual private server, but it's not a full OS, and it only works in a container. You couldn't run it in a virtual machine. So that's just, I needed to give it a name, so I'm calling it MicroVPS. So what are my requirements for a MicroVPS? And this is really just how I laid out the challenge to have something to do. Because again, this is all in the frame of being a learning exercise, so we can really learn the internals of containers. So you want to have a minimal runtime. Right? A runtime environment that is just what you need and nothing more and doesn't have any of the external OS processes that aren't part of this. It needs to be in its own namespace. Right? I want it to have its own interface, its own IP address. To the world, I want it to appear as if it's a server, even though we know it's not. And that also means its own routing table, so forth. Because I'm lazy, I don't want to have to invent a new package format or something like that. I'd just like to use something existing to install software in there. So I'd like to have some kind of, I say native, meaning that it's already existing, and if it's CentOS you're after, you're using RPM. If it's Debian you like, you're using Deb. It's some native package tool. And then, of course, the automated build. That's got to be there. Right? It's got to be something we can put some code in a repo, other people can check it out and build it. That's important. And then, of course, if you've ever spent time developing the solution for what's in your container, build time is critical, right? It's not like the old days where it was perfectly acceptable to go spend an hour doing something while you wait for a build because there was no choice. Things were that slow. Now computers are really fast, so we need to have an iteration cycle where in between testing we're not going insane waiting for the next run. And then some kind of way to deploy and manage it, right? It's not really a container solution if we don't have some way to deploy. And when I say manage, I mean it may be just as simple as starting the instances and stopping them, right? Just some way we can manage it. It's at this point that I always call stop on myself. And what's happened is I'm sitting with a couple of friends, we're drinking a few pints, we're just brainstorming and talking about this wonderful world of containers, and our thoughts just drift off into the world of what could be possible, and you endanger yourself in terms of falling into the trap of creating a solution that's looking for a problem. Right? You may work with certain people that do this, and then you sort of wonder, how did we get down this road, and why are we trying to do this in the first place? So I always like to recall the famous words, I think it was Abraham Lincoln. That's a joke for the Americans. What problem are you trying to solve? If you don't have a good answer to this question, then you're engaging in fantasy, which is fine, but don't do it on work time, please. So for us, the problem is a learning lab. And I had a very concrete problem here. And the problem is that I was given a task. I'm a big believer in learning, so inevitably, whatever organization I'm in, I end up doing these sort of learning activities and building a lab. And we wanted our engineers to get a lot better at building clustered monitoring and alerts. Right? Because when you go from like individual node monitoring and alerting to cluster, it's a whole different situation, and you need some way to develop and test and see if what you're doing makes sense. And so I wanted to build a learning lab for this, but the learning lab that we had, you get one laptop in there to run the lab infrastructure. And if you think about clustered alerts, that means that if I have 16 participants in a session, they each need multiple servers to test their alerts against. Very quickly, we run beyond what one laptop could support. So that is the problem that I used to motivate this project, and it was a real problem I needed to solve, so it's a good combination of things. So what does my learning lab require? Well, in this case, 20 to 50 virtual servers need to be able to exist in this learning lab, and again, I have one laptop to do this with. It's that single physical server that is the laptop. It needs to be easy to set up and tear down, because if I'm going to give this session every week or so, it can't be something that takes me a lot of time to set up. All right, so how do I translate what I want to do with the Makefile MicroVPS into something for the lab? And here's where I look at these requirements. Again, it's got to have a dedicated IP because we're pretending they're servers, and we're going to have monitoring tools checking them and checking the health on the services they're running. In this particular case, the lab stuff they were developing, it's all testing against HTTP, so there had to be an HTTP server on our virtual server. And they need to have SSH root access. And this one I thought was a fun requirement, because if you look into most container documents and how-tos and best practices, the first thing they tell you is, if you're putting an SSH server in the container, you're definitely doing something wrong. Which you could argue in production, that is probably a good policy to follow. But in a learning lab, in this case, this requirement actually came out of something funny. I had set up automation so that the learners, the attendees taking the lab, could just hit a button and kill their servers, and pick the ones they want to die off and then test their alerting. And I got this weird feedback. And this weird feedback was from all these software engineers saying, we want to be able to kill the fake production environment. Like, we actually want to be able to log in and just kill the servers manually and do the things we're never allowed to do in production. And I was like, oh, OK. Well, I believe learning labs, you should have the freedom to do whatever you want. So sure, we'll throw the SSH in there, and you can go in there as root and wreck up that file system any way you want and watch, simulate whatever failure comes to mind. Sure. All right, so of course we need to select tools. And I always like to share my philosophy of tool selection. I promise you the hands-on stuff is very shortly coming. And so how do I go about selecting tools? Well, I have a few rules I follow, and some people tell me I'm crazy, but this is how I believe things go. When I want to build a reliable system, right? I don't want this lab to fail halfway through, because if the lab is failing, people aren't learning the right things, right? They're trying to test cluster alerts, the whole thing's not working, they don't know if their stuff's working. It's got to be reliable. So something standard is always going to be better than something disruptive. If I need to hire people that know how to support it, I have better odds with the first one. Now again, this is conceding that all things are equal, right? The tool you need, there are available choices in either camp. Something that's battle tested, I have more faith in than something brand new that I don't have any history on or know people that are running or haven't seen the way it fails. Simple is always better than complex. There's some people who someone recently said this, a lot of people mistake elegance with complexity, right? And they sort of get it wrong, or nuance does not mean complexity. There are a lot of attributes to reliable systems, and I don't think anyone would ever argue that complexity is one of them, right? It's the thing that we try to avoid. So if I can do something a simpler way, even if it means I have to learn something new, like a new tool, that to me is better than doing something really complicated. And then modular is monolithic, right? If it's modular, we can take it apart, we can play with the pieces, we can change out part of it. If it's monolithic, it's everything or nothing. So these are better. And then the last one, and a friend of mine got really upset when I told him this point. I said, built-in is better than add-on. And he said, well, but I know there's things I need to add on before I even set up a server. I said, yeah, that's not what I'm talking about, right? It's not like you're choosing between the built-in Hadoop versus the one you add on, right? What I mean is, if there are two tools that could do the job, and one of them's already in there, that's better because you have no maintenance work of packaging some additional tool. If the one that's in there can't do the job, or there's nothing in there that can do the job, of course you're going to add on software. But given the choice, I like to go with built-in. All right, so what are we going to use today? What are the tools? We're going to use Make, GNU Make. Anyone ever used that before? Yeah, it's great. It's been around forever. It's well understood. And it just happens to be, it is a tool for automating the build of things. So hey, it's a good fit. We're going to use Yum. I chose a package format. We're going to install packages. We'll use Yum. That's what it's for. Systemd. It comes with the distribution, so it's already there for managing services. And that was one of the things we needed. So we'll use that. IP route tool. As you saw, if you came to my talk last year, this is a tool that lets us access all different kind of parts of the network namespaces and the networking. And we want to have networking in our containers, so we need a tool for that. And rsync, just because a quick way to copy files efficiently, right? So rsync's there, and we're going to need to copy files into our container. And then bridge utils. So the bridge utils, these are the tools that allow us to manipulate the Linux bridge devices that show up as part of the network stack. That's pretty much it. That's all we need. Everything else is built in. So first thing we're going to do is we're going to do some setup. And we're going to start, again, with a minimum CentOS install. And we're going to prep it for being able to build and run containers. All right. I just realized something, that we got this all set up, but I forgot to check, actually, because this is brand new, as I promised, from scratch. I don't know what the IP is. All right, cool. Oh, and it's probably... So if you are following along and you have your own virtual machine installed with minimum CentOS or Debian, this is where we're beginning. All right. Sorry. OK, so the first thing we need to do is we're going to need to install some packages. And I mentioned there really aren't many. And we're going to do bridge utils, because that is not part of the default build. Rsync is also not part of the default minimum CentOS install, and we're going to add the IP tables services, which this is actually the older way of managing the firewall in CentOS. All right, so we got those in there. And the next thing we're going to do is disable the firewall. And can you guys see that OK, or is it better at the top? Does that work? Good? OK, cool. So system control, we're just going to stop firewall D, if I can type correctly. I promised to make a few typos to show you guys how things break, by the way. And we're also going to disable it. It's funny, to me, like, firewall D is a really neat automated tool if you really want a complicated firewall setup. We're also going to disable SE Linux because it's not part of the lab, and you could use it with this stuff, but we're going to kind of throw that aside for now. And to make this permanent, you're going to want to edit etc sysconfig SE Linux, of course. And by making it permissive, of course, we can still catch the warnings, but we won't actually have to have it block us. We need a bridge. Our containers need to be able to reach the network, so it's going to require adding a bridge. So on CentOS, we're going to create a file. And I'm going to call it ifcfg-mvps for MicroVPS, br0 for bridge 0. And we'll call it the same name, By the way, if anyone sees a typo, don't be shy. If I don't see it and you do, it's better if you just yell. All right. Oh, wow. All right. There's a solution to that, I think. Oh, the border's off of there, too. All right, let's see. We can... How about like that? That work? Yeah. All right, cool. That should be good enough. That's the kind of feedback that's valuable. All right. It's going to give it an IP, and I'm just going to pull a number out of the air. And we're going to give the bridge an IP so that the host can use it to talk to the containers, and the containers can use the IP to route out. Most important line in here to make sure this works is that we identify its type as bridge and not Ethernet. And because it's statically configured, we do need to name the device. That's also MVPS BR0. And I don't know how many of you guys are fans of Network Manager, but we'll just leave it out of the equation here. And last line is onBoot equals yes, because we want it there when the machine reboots. All right, so I'm going to save that. And the best way I've found to test whether you did this correctly is just to try to bring it up. If up, MVPS BR0. And if it looks like it worked, and we've got a configuration on it, don't worry about the fact that it's down or that it has no carrier. It's a bridge with nothing plugged into it, so that's fine. We have a couple more things we need to do. And we want to be able to, again, have our containers traffic route in and out. So we're going to have to make a quick change. We're going to create a little file in rc.sysinit.d, which is now you can, instead of editing the main one in CentOS 7, you can just put any old file in here. So we'll call it LCFS, Linux Containers from Scratch. It just has to end in .conf. And what goes in here is really not much. It's just the setting you want to change in syscontrol. And that's it. So one-liner, drop that in. And again, to verify that you did that correctly, you can just ask the syscontrol to process it. And it reads it OK, so good to go. All right, we also need to do the firewall. So we disabled the firewall in terms of firewall D. So there should be nothing there. But any guess on what we need? Yeah, the masquerade. Exactly, because if we want our traffic to get out from that private network, we have to masquerade or provide a NAT for it. So we're just going to say add a rule to post routing. If the source network is 10.100.10.0/24, then send it to the masquerade. And if you don't get an error, that means it worked. To make this persistent, this is where the package we installed comes in, IP tables save, and we just write it to etc sysconfig IP tables. All right, and last thing we have to do to make that persistent is system control. How many people here actively use systemd and system control to manage things? Anybody? OK, so almost no one. And of you that do, how many alias it to something else? Seems like a good idea, right? It ought to come that way. So last thing we're going to enable is we're going to enable the service, and it creates a symlink. The service is enabled, so that's groovy. We have a couple more things to go to be set up to make this work. The tool systemd nspawn is one of the tools we're going to use. It complains about having issues with kernel auditing, and so currently they just recommend that you disable that, which that makes sense, right? So we're going to go etc sysconfig grub, and we're going to go to the kernel command line and just add audit equals 0. And save that. And of course, that's not going to make any change until we process it. So we use grub2-makeconfig. And we say output to boot grub2 grub.config. So that'll rebuild it, and now it should have that flag set in there. And the other advantage of doing it this way is that if you install a new kernel, it'll pick up the flag as well, add to the new kernel. All right, so at this point, we need to reboot, because we made a kernel setting that's not going to take effect until we reboot. So here we go. And that shouldn't take very long. And again, if you look at the time that this is taking to reboot, think of that. That was really fast because it's small, but that little delay there was all that stuff that would be attempting to happen in your container if you were trying to boot the whole OS, but instead of having a real reason to happen, it would just be taking up time. All right, so we've rebooted it. Get back in there. And now we're ready to really get into our container building project. So first thing we're going to do here is we're going to build a directory just to hold our project. And I'll call this directory demo. And go in here. We're going to use yum to install packages. But one thing about yum is it's built into yum that it defaults to checking etc yum.conf and then also to checking etc yum.repos.d for additional configuration. And even if you make a yum.conf and pass it, that'll stop it from looking in etc yum.conf, but it will still look in yum.repos.d unless we explicitly configure it not to. So we're going to make a quick yum.conf to control exactly the behavior of yum, because otherwise you can't have a predictable build. If you can't control your software sources, you don't have a predictable build. So I'm going to just do that real quick in this directory. Again, no typos. There we go. So we make a main section. This is for the main options. And we want assume yes, so that it won't stop and prompt when we're running it via make. Because we're installing in a container and we want this to be as minimal as possible, we want to say keep cache equals no, 0. We don't want anybody to, or we don't want yum saving anything that it downloaded. Here's another one you can throw in there, TS flags. And what this is you can pass flags to RPM, and we're going to say no docs. So we're not going to install man pages in there. Right? You're really having a weird day if you're logging into a process in a container and running man. Right? So we definitely don't need those. We do want to ensure package integrity, so we're going to put this guy in there, GPG check 1. I want yum to be as fast as possible, so I'm going to disable plugins. Distro version package is how you tell yum, if you're yum and you have no root file system to look at and you've just been handed a minimal config, how do you know what the version is? And you can just say, well, whatever the version of this package is, that's what the version is. Because yum needs a notion of the version. So we'll just say CentOS-release. That's always a good choice, because that's kind of the point of it. And then the last thing here we need in this section is that repos directory. And again, this is where you would normally configure your etc yum.repos.d. But what we want to do here is somewhere where there will never be any repos files. Any suggestions? That works. Right? Like even if someone copies a repo config file, it won't be there. And then the last thing is, just to save time on my builds, I'm going to install from the CentOS DVD. So by the way, if anybody needs a copy of the DVD, if you want to follow along, you don't have it, and you want to do the way I'm doing it, but you don't want to wait to download it, I do have some USB keys prepared. Does anybody? No? OK. If you do, they're here. I'll give them to John, so if you want them, he'll have them. All right. Yeah. All right. And then, so here I'm going to just identify the repo. And we'll call it CentOS 7. The base URL. This will be where we mount the image. And you got to tell it where the GPG key is, because we insisted that we wanted GPG checking. But if we don't put in a path to it, then it'll just error asking for where it is. So we'll point to the one on the host. Since if you're not running a CentOS host, you obviously have to have this key somewhere else. All right, last part here. All right, so hopefully there are no typos in there, and that'll work. I now just need to do a couple more things, and then I actually have to make that directory for the CD-ROM. And it should already be in my virtual machine's drive, so I'm just going to mount it. Yeah, I figured. All right, and cool. So that's mounted up. We can check the contents. It's just a standard ISO. We're good to go there. Now, there's one other thing in that I need to. So there's no way I could type through every part of this and have a functioning system and meet the time limit. So I have pre-made just a few files that are not relevant to the setup or mechanics of it, but are just things that are like payload for the container, like the web page, things like that. So because this is freshly installed, I just need to push that archive up there. Where's my other terminal? I'll just make a new one. So there's nothing really exciting about this other than it's just a bundle of those files. All right, cool. Now we're ready to make some containers. So we've gone ahead. We now have this container directory. It's got nothing in it but a yum file. So we make a new directory to contain an actual container project. We'll call it web1 if it's my first web server. And I make a subdirectory in there called fstree. And the point of that directory is this is where I'll store the payload that I want copied in to my container in this kind of build. And you'll see how that works. And then, of course, we also need a Makefile because this is going to be a make project. So what we now have is the setup directory. It's got an fstree. It's got a Makefile in it. All right. So real quick review on the setup. So we've gone ahead and installed a few packages, created a directory and mounted the CD. So that'll be a source for yum when we install packages. We stopped the firewall, and we disabled it. We stopped firewall D. And then, of course, we set SE Linux to be in permissive mode, and we also made that permanent at boot. Created a bridge interface, and we added that to the system. So the bridge interface comes up with the IP address 10.100.10.1. We activated it and saw that it worked and got the right config. Then we enabled IP routing so that we can pass traffic out and have our host act as a router. And we made that permanent at boot time, and we also set natting masquerade with the firewall. We made that permanent as well. We edited the grub command line so that we can disable kernel auditings, because that makes systemd nspawn happy. And we updated our grub config, and we rebooted. Created the yum config for our installation source that should match where we've actually put the CD, or if you have the ISO image, you can just mount the ISO there. And we created an empty project. So what does my container project look like? Looks like that. If I'm going to be building containers, I have a top directory where I've got my yum file, and then I've got one directory per container. They each have an fstree directory where I'll put my sources that want to go into the container, and then, of course, a makefile. All right, so we're now going to try to build a container. And the first thing we're going to do, if you remember my requirements were that it had to have a web server and it had to have an SSH server. SSH is built into CentOS, so that's not a problem in the minimal install. There's no web server in the minimal install. So we'll just do Apache, not because I think it's the best web server you should run, but because it's there, it's easy, and it works for my lab. There's no hardcore performance requirements. All right. Let's see if we can make a working container. So we're going to edit that makefile, and we're going to put in some variables. And these variables, you'll see they just come up to make configuration easier. So we named it web1. We're going to make a variable called packages. And this will simply be the list of packages. We have to tell yum exactly what we want, because it's just yum running with that bare config. And I want the minimal install group. So this is the way we identify a group, minimal install. And then what else we wanted? Apache. Its package is called HTTPD. What IP address should the container have? We'll give it 10.100.10.21 because that's a good choice, I think. We'll have a gateway. What's the gateway going to be? What? Yeah, .1, because that's the one we put on the bridge. So that's the gateway. Rootfs, this will be where the container image is built, and we'll just call it rootfs. Little name for our yum config, where are we going to have that? And if you remember, that's one directory back. Yum requires that we pass it the CentOS version. Again, this is just a quirk of running it in the minimal config way that we're running it. And then we want to identify the path to the FS tree. All right, so that gives us some config variables. We're actually going to need one more, also bridge. And if you remember the name of the bridge, it's MVPS BR0. All right, so that's just some config data for our container. Let's make a target here called container. Seems good, right? And so what do we want to do first? Make directory for the rootfs. Now, what happens in make if one of the commands in a target fails? What does make do? Anybody? Stops, yeah. And this is actually, to me, a really good property, because in this case, since we're going to be putting all these commands, if something goes wrong, we just want it to stop, not like a shell script where it's just going to keep rolling along. But also, if this directory exists, is this command going to fail? Yeah. And we want it to fail because I want to make sure I'm doing a clean build every time. So this is just a little thing I put in there, so I know the directory will exist, and I know it was just created, or make will have stopped. All right, so we're going to say now, just get with the installing. So we have to tell yum the config file to use. And you can space it however looks good to you, but I try to make it look a little bit clean. -- install root. And this is telling yum where to install. Now, one quirk about yum, and this is a thing I discovered that really bit me in the ass. When you tell yum an install route that's alternative instead of /, it must be an absolute path. If it's not an absolute path, it won't do what you think it's going to do. Thankfully, make has a nice macro for this called abspath. So you just say abspath, and then you tell it rootfs, and that's where we want it installed. And here's where that release version goes. We're almost done with this, believe it or not. And then we also need to actually do a command, install our packages. And that's it. That is the command that will build, will be the first yum command. Now we're going to add one more yum command in here. The second one we're going to do, and in fact, I'll just copy and paste a little since that'll be slightly faster. Use the exact same config, only the last line changes. And anybody want to guess what I'm going to put here? I know it's a little bit of a shy crowd, so I'll just show you. I'm just going to put that. So this will cause yum to clean up some metadata so that the container image will be a little bit smaller. All right, now that's it. That should be enough to make a very basic container image file system. So I'm going to save it and run it and see if it works. This should take about 90 seconds, at least in my previous tests. So it's going to install those packages. And I was actually talking to my wife about this last night and debating whether or not this could happen and people wouldn't lose their patience. And she said, well, if you have that time, you could always tell that UDP joke. And I said, I don't really want to because people don't always get it. Oh yeah. Sorry. Yeah.
This would technically be multicast.
Fair enough. Yes. So, I was going to tell this joke John told me about NTP, but I never get the timing as well as he does. So, all right. Anybody got any? Yeah, we're almost there. It's good stuff. Yeah, I remember one night back in about 2010, Twitter lit up with an entire evening worth of protocol jokes. Anybody remember that? Good old days. All right, we're just about there. And boom, we've created something. Let's see what we've got. So we'll ask for the size. It's about 565 megs, not bad. It will compress to about 200 megs if we compress it, make a tarball. So that's pretty good. But this is almost useless. Like, this is like a base of a container. It's not configured for anything. So this is where I'm going to go to some files that I had pushed out here just to have some payload. And so what I'm going to do is just copy, and we'll discuss the exact files. I promise there's no black magic here. So we're going to copy that FS tree up. All right, so we've got the FS tree. It's got some files in it. We've got the Makefile. We've got that rootfs. One more thing that might be handy in our little Makefile is, because we're probably going to end up doing this more than once, let's add a clean real quick. So we can say make clean, and this will be really simple, rm-rf rootfs. All right, so I'm going to clean it this time, and we'll do the build again. And it's only 90 seconds, and I promise I won't repeat those jokes. Unless you want, I can repeat them exact. But this is where you're thinking iteration cycle, right? And you're thinking, OK, is this fast enough that I can be sane and wait a minute and a half for each test? Or is this something that's just going to make me crazy? There are lots of creative ways that you could dramatically speed this up. And really what it comes down to is not doing this over and over again. Right? Because every time you do this, the output should be exactly the same. It should produce that same directory of files. So I'm sure you guys could think of easy solutions for that. Like you could tar it up, so you just have it there and untar it. That would probably be faster than cracking open all the RPMs. You could leave it untarred and just maybe make a copy to a fresh directory before you then mutate it. Right? So something like that would also make it faster. I think it's open to creative interpretation. I'm not going to do any of those things, though, because it's just fun to ramble on. OK, so this time, we forgot to add something to the Makefile. We didn't do anything with those files. It's OK, though, I have a shortcut to speed that part up. How do we get our custom payload in there? Well, remember rsync? We'll just put that in here. And we're going to rsync from our FS tree into our rootfs. Very simple. So that will be the part that then installs the custom payload. I'll just run the rsync command, though, if you guys trust me that I typed it correctly in the Makefile. Maybe. All right, so same command. So we've thrown some files in there. All right, cool. So now we have a container. You can see I put activation of HTTP, threw a little payload in there. But what we don't have is really any way to run or test it, right? I mean, like I can call systemd nspawn, which is the tool that comes with the system, and that's what's built in. And this will launch a container if I tell it, OK, here's the directory, and I want you to boot it. And it's going to start things up. You can expect to see some failures, because it's, again, trying to boot up a whole OS, and there it is. But what it didn't get, if we log into this thing, if you type it right, let's see.